The following question is about moles and empirical formula, and the question states that in leaded petrol there is an additive composed of lead, carbon, and hydrogen. So there is the compound has lead, carbon, and hydrogen, and this compound contains 29.7% carbon and 6.19% hydrogen by mass. So you're given the percentage composition by mass. So you have carbon and you have hydrogen, and the percentage composition by mass is given. It's 29.7% carbon and you have 6.19% hydrogen. So the first thing you do is you find the moles. The moles would be the percentage mass divided by the atomic mass, which is going to be 29.7 divided by 12, and for hydrogen it's going to be 6.19 divided by 1. So the value that you're going to get is, using my calculator, 29.7 divided by 12, 0.7 divided by 12 gives me 2.475 moles, and 6.19 divided by 1 would be 6.19. That would remain the same. Now I want to find the simplest ratio. To find the simplest ratio, I would pick the smallest number and divide both values by that smaller value. So between the two, the smaller value is 2.475. So this would be 1, and I would divide 6.19 by 2.475. Then that would be, so it's going to be 6.19 divided by 2.475 on my calculator. The value that I get is approximately 2.5. So what this means is that the ratio of carbon to hydrogen is, for every 1 carbon there would be 2.5 hydrogens. Now if you look at the question carefully, in the formula there are 8 carbons. So what we are going to do is, we already know the ratio. So for 1 carbon there are 2.5. So what would be the amount if you have 8 carbons? Then according to the same ratio, if I multiply 8 by 2.5, the value that I'm going to get is going to be 20. So according to the ratio, 1 carbon has you have 1 carbon and you have 2.5 hydrogen. So the ratio of carbon to hydrogen is 1 ratio 2.5, but the formula has already given us the amount of carbon, that which is 8. So according to the same ratio, if you have 8 carbons, the amount of hydrogen would be 20. So option D is going to be the correct answer, because hydrogen over here, they exist in 1 ratio 2.5. So 8 carbons would combine with 20 hydrogens.